Hello, I'm Professor Von Schmohawk, and welcome to YU. In the last few lectures, we studied several forms of linear equations and saw how they can be applied to various types of real-world situations. In this chapter, we will lay the groundwork for solving real-world problems which involve percentages. The word percent is derived from the Latin word percentum, meaning per hundred. Percentages are one method of describing a fraction of a quantity. This fraction is always given in hundredths, and the percentage specifies the number of hundredths in the fraction. In other words, a percentage is the numerator of a fraction whose denominator is understood to be 100. Instead of writing the word percent, percent is usually denoted by the percent symbol. To understand percentages visually, let's start with the quantity x, which can be divided into 100 equal divisions. We can visualize 1% of x as 1/100th of x, or 1 division. Likewise, 25% of x is 25 hundredths, or 1/4 of x. 50% of x is 50 hundredths, or 1/2 of x. And 100% of x is 100 hundredths, or the entire quantity x. Percentages can also have values greater than 100 and thus represent values greater than the original quantity x. For example, 150% of x is 150 hundredths, or 3/2 x. So 150% represents a 50% increase over the original quantity. Likewise, 200% of x is 200 hundredths, or twice x, which represents a 100% increase over the original quantity. In these examples, we converted percentages into equivalent fractions with denominators of 100 and reduced those fractions to their simplest form. Percentages can also be converted to equivalent decimal numbers. Instead of converting a percentage to a fraction with a denominator of 100, we can convert the percentage to a decimal number which is equivalent to that fraction by dividing the fraction's numerator by 100. In this example, 15 divided by 100 is 0.15. Of course, we could produce the same result of dividing by 100 by simply dropping the percent sign and shifting the decimal point 2 digits to the left. Decimal equivalents of percentages are sometimes easier to work with. For instance, instead of writing 15% of x, we can simply write 0.15x. Let's say, for example, that out of a class of 40 students, 15% received an A on a test. We can find the number of students who received an A by calculating 15% of 40. To do this, we multiply the decimal equivalent of 15%, 0.15, times the size of the class, 40. The result is 6. So 6 students received an A. The decimal equivalent of a percentage can be thought of as a ratio of the percentage amount to the entire amount. In other words, the amount after the percentage is taken to the amount before the percentage is taken. In this example, this is the ratio of the 6 students who made an A to the class of 40 students, or 6 over 40. 6 divided by 40 is 0.15, which is the decimal equivalent to 15%. Determining the ratio of quantities is an easy way to calculate percentage. For example, to find what percentage 6 apples is out of a total of 75 apples, we compute the ratio 6 to 75. 6 divided by 75 is 0.08, which is the decimal equivalent to 8%. In this chapter, we have introduced the concept of percentages and explored the principles on which percentages are based. In the next chapter, we will use algebra to solve real-world problems which involve percentages.